Today I'm going to teach you about density and density in mixture. So what is density? Density is basically mass per volume of an object or a matter, not just object but any types of matter. It can be either solid, liquid, gas, or plasma. All of them do have density. So the density is defined in physics as rho. Its symbol. So this rho represents the density. Now let's talk over some densities, like the density of water. So the density of water is 1000 kilograms per cubic meter. Kindly take down some notes because this is very important. So the density of aluminum is around 200 2700 kilogram per cubic meter. So as we can see, aluminum is much denser than water, which means if the aluminum is in liquid state, you will basically float. So the density of air is 1.29 kilograms per cubic meter. So compared to water and aluminum, the density of air is pretty small. That's why we can just walk around here, right? So now let's go to some problems. So what is the mass of air that fills a rectangular room that measures 3 by 6 by 9 meters? So we all know that density is equals to mass per volume. We know the density of air, which is 1.29 kilogram per cubic meter. And the mass, that's what we're finding for. So to get the volume, we can just know this, that the rectangular volume is 10 times width times height. So 3 times 6 times 9. 6 times 3, let's say 9 times 3 first. So 27 times 6 is going to be 162 cubic meters. So this is the volume of the rectangular room. Now we can just do cross multiplication and we will get the answer in kilograms. Cubic meters will cancel, so we get the mass. So the mass of air that fills this rectangular room is 208.98 no m, not m, but kilograms. So the mass of the air is pretty high, right? What is the weight of a large spherical balloon filled with air that has a radius of 5 meters? The mass of the balloon skin is 0.25 kilograms. So density is equal to mass over volume. So we do have mass, it's 0.25, and let's find the volume first. So to calculate the volume of this spherical balloon, so in geometry, it is spherical, which means the equation that we're going to use is this thing. So 4/3 pi r, and the radius is going to be 5 meters cube. So the answer here is going to be, the volume is going to be this number, this magnitude, 523.559 500. Oh my god, I think I'm gonna write everything. So this is the volume of the spherical balloon. We also have given of the air. It is basically filled with air, which means that it has the density of 1.29, and the mass is just this. So this mass is the mass of the balloon itself, not the balloon skin. So they are two different things. So we're just going to cross multiply this thing. Let me just delete this. So the mass of the balloon is basically this number, 665.44 kilograms per cubic meters. So as we get the mass of the balloon, we're finding the weight. So the weight is going to be mass times grams. Gravitational acceleration. So the mass is going to be 675.444 plus the balloon skin, which is 0.25. And then we're just going to multiply it with the gravitational acceleration. So this is going to be negative 6,628.6 newtons. So this is the weight force that is acting on this balloon. So this balloon is not going to go up, is it? So it's just, that's the force that's acting on this balloon. 100 liters of water is mixed with 50 liters of ethyl alcohol, which has had a density of 789 kilogram per cubic meter. What is the density of the mixture? So to calculate the density of the mixture, we need this. So density of the mixture is equals to the total mass divided by the total volume. So as we know that the density of the water is equals to the mass of the water divided by the volume of the water. What we're going to do here is just solve for the mass of the water. So we will get this. So we have the density of the water and the volume of the water. Now let's go back to our original equations. So the density of the mix is it going to be, we're going to substitute this. So this is just same as mass of the water plus mass of the ethyl alcohol. So let's call it M sub E. So the volume is just going to be staying the same. We're not going to say that the volume of the water plus the volume of alcohol. We're not going to break it down. So the density of the ethyl alcohol is equals to mass of the alcohol divided by the volume of it. So cross multiply, solving for the mass of the ethyl alcohol, we will get this. So what we can do now is just basically substitute everything here. So we're going to replace this thing with the density of the water and the volume of the water plus the density of the ethyl alcohol and the the volume of ethyl alcohol. So we can split these things. We can split the volume here, right? So the density of the mixture is going to be the density of the water and the volume of the water divided by the total volume plus the density of the ethyl alcohol and the volume of ethyl alcohol divided by the total volume. See, it's just algebra. So we all know that the density of the water is 1000 kilogram per cubic meter and the volume of the water here is just 100 liters. So the volume of the bottom is going to be 100 plus 50. So we're not going to take consider of the units here because liters will just cancel at the bottom, right? So that's it. The volume of the total volume is going to be 100 plus 50. So we're just going to use this our calculator. 1000 times 100 divided by 150 is going to be 666.7 plus 799.89 times 50 divided by 150 is 263. So taking the sum of these two, so the density of the mixture is going to be 929.7 kilogram per cubic meter. And that's basically it for this video. I hope you learned something and